The value of a bond is similar to the value of everything else. It's just the present value of the expected cash flows. So in the case of a bond, we know what those expected cash flows are because we can get that from the coupon rate and the time to maturity and how often coupons are paid and the face value. We know that it's coupon, 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 and at maturity par value. We've made some simplifying assumptions, and so we know the next coupon's in one period. And so it's coupon over 1 plus r plus coupon over 1 plus r squared, all the way out to the last coupon. So that raises the question, what do we discount it by? And the discount rate is based on the yield to maturity. And basically, if coupons are paid, and remember, yield to maturity is an annual rate. So if coupons are paid annually, if this corresponds to a year, then the discount rate is the yield to maturity. If, oops, I didn't change color, but if this period from time now until time 2 represents a year, because each of these are a half year, you need a 6 months rate, or you need a 6 months discount rate. Then all you do is take the yield to maturity and divide by 2. Conceptually, very straightforward. So again, here's the equation for it. Coupon over 1 plus r plus coupon over 1 plus r squared, all the way out to the very last coupon, if there's t of them, plus par value at time t. Par value is just the par value of a bond, which is equal to $1,000 in this class. Coupon is the coupon payment. Remember, it's the annual rate times par, which captures how many coupons there are, or how much is paid in coupons over the course of the whole year. Then you have to divide by the number of coupons per year to get what each coupon is. R is the discount rate per period. So again, it's the yield to maturity, which is for a whole year, divided by the number of coupon payments per year. And T is the number of periods. It's the number of years until maturity times the number of coupon payments per year. So notice there's a couple of cases where you divide by the number of coupons, and then one case here where you multiply. Understanding why makes it so memorization is not necessary. So if you're operating in a world where you're in 6 months, then clearly for the coupon rate's annual, so coupon times par tells you how much gets paid over the course of the year, so you need to divide to it to get to 6 months. R, you need the discount rate over a 6-month period, so you have the yield, which is an annual rate, divided by the number of payments. But then the number of periods is the number of years, but there's 2 periods per year, so that's why you have to multiply. A couple of notes. When we talk about the value of a bond, again, it's its present value, which is its market value or price. Again, value equals, it doesn't equal par value or face value. If you're talking about par value or face value, you guys will be told, or it'll be explained specifically what that is. It'll be mentioned. And again, the price in a well-functioning market equals value, because if the price was too high, nobody would want it. If it was too low, everybody would want it. And so you need that for equilibrium. Another note, suppose we're valuing the bond at the same time that a coupon's paid. So we are getting it on a particular, and again, that's going to happen a lot, because if the next coupon's in 6 months, then there was a coupon today. One of the questions that could come up is, do I count the coupon, do I not? We don't. We're always going to assume the next coupon is in, one period. So one way to view it is that coupons are paid in the morning and we value bonds in the afternoon. So therefore, when the afternoon rolls around and it's time to say how much is this bond worth, the coupon that was paid on that day has already been paid. It's already out the door. It's already in the mail. So all that matters is what you're going to get, and the next one's in one period. So here's a nice reminder. Coupon rate stamped on the bond. Face value, $1,000 stamped on the bond. Maturity stamped on the bond. And frequency of payments, semiannual or annual. That information, again, it's stamped on the bond. They're fixed in this class. And they tell us when cash flows are expected to take place. They tell us when cash flows are expected to take place. So they're fixed, they set cash flows. In order to value the bond, you need to take the present value of that. So you need a discount rate. And that comes from the yield to maturity. And what the yield to maturity is based on is the risk of a bond the yield to maturity at a point in time is based on the risk of a bond at that point in time. And that can change over time. We'll talk about that later, but the bottom line is bonds, because of underlying business conditions or firm conditions or the way a project's going or a lawsuit, a bond can be perceived as being more or less risky at one point in time than another point in time. So again, remember, these tell you the cash flows, that tells you the discount rate. So in the calculator, we're dealing with a set of fixed coupons, and that looks just like an annuity. So again, we're in end mode, and the payment's equal to the coupon, which is the annual coupon rate times par, divided by the number of coupons per period. How many of them are there? There's n, which is the number of periods until maturity, times the number of payments per year. Par value, always going to be 1,000. So par value and end mode are universal in this class with bonds, because par FV is always going to be 1,000, and end mode because the next coupon is always going to be in one period. So finally, you need I%, the rate at which you discount everything, and that's just yield to maturity divided by the number of coupons per year. And you solve for PV, and up on the calculator pops the opposite of the present value. That's the cash flow that would be needed, to purchase a bond that would promise you the cash flows that you've set, end payments of the coupon plus par of 1,000 in end periods. So let's look at a few examples. We have a bond with 4 years to maturity, coupon rate of 10%, annual coupons, par of 1,000, yield to maturity of 11, next coupon's due in a year. So 10% of 1,000 is 100, so in 1 year, 2 years, 3 years, and 4 years is 100. Then the bond matures, and we get our 1,000. So what do we discount by? We have 11%. 11% is an annual rate, so that's our discount rate. So this is the value of our bond. 1,000 over 1.11 plus 1,000 over 1.11 squared plus 1,000 over 1.11 to the third plus 1,000 over 1.11 to the fourth. 100 over 1.11 to the fourth plus 1,000 over 1.11 to the fourth. Add it all up, 968.98. And why is it 968.98? Because in this case, I'm going to get a different ink color so it stands out. You expect $1,000 in a year, discounted by 11%, that's worth $90.09. You expect $100 in 2 years, discounted by 11% for 2 years, that has a present value of $81.16. 103 years, that coupon is worth $73.12. The 104 years is worth $65.87. And the $1,000, the par value in 4 years, is worth $658.73. Add them all up, and that's what the bond is worth. The bond is equal, you've got these 5 payments. So if I were to ask a question, what is the present value of the coupon expected in 3 years? The answer is 100 divided by 1.11 to the third. That's worth $73.12. You can let the calculator do all the work for you. Again, end mode telling it the next coupon's in one period. FV of 1,000. What are those payments? It's equal to just 10% of 1,000, and there's only one of them per year, so you set payment equal to 100. There's 4 payments, plus it matures in 4 periods, so N is equal to 4. I% is 11, that's the discount rate, and solve, and you get negative 968.98, so the value of the bond's 968.98. How about semiannual coupons? So we have a bond with 5 years to maturity, coupon rate of 10%, but now we have semiannual coupons, par of 1,000, and a yield to maturity of 11%. Next coupon's due in 6 months. So 5 years to maturity is actually 10 half years. and 10% of 1,000 is 100, but there's semi-annual coupons, so there's 2 per year. So in 6 months there's 50, 12 months there's 50, 18 months there's 50, and that happens all the way out here to in 4.5 years, and then in 5 years there's 50, and then in 5 years there's 1,000. And what do we discount these by? Well, the 11% rate corresponds to a whole year, which is from here to here. So we need the rate for 6 months, so it's half of 11%, so it's 5.5%. So the value of this bond is equal to 50 in 6 months, where the discount rate is 5.5, and then another 50 6 months later, which is 12 months. So notice, even though the yield to maturity is 11, the value of that second coupon is not 50 over 1.11, but because we're dealing with a world where our timeline is semi-annual, it's 1 plus the 6-month rate squared, 1.055 squared. And it's like that for all 5 years, including 1,000 in 5 years, which is really 1,000 in 10 half years, discounted by 5.5 per half year. And the value of this bond, $962.31. And we'll do it in the calculator in a second, but remember, we looked at the value of this coupon in 3 years. It was $73.12. Notice in the semi-annual world, because the discount rate is 11% per year, but because we have semi-annual compounding, that bond, the one in 3 years, oh, actually, it's not apples to apples because it's 50 divided by 1.055 to the 6th, and so that coupon is worth $36.26. So if it's annual, you divide it by 1.11 to the third. Here we divide it by 1.055 to the 6th. It's semi-annual. And again, the reason the bond is 962.31 is because the value of all 10 of the coupons, and you can see them there, plus 585.43, which is the value of 1,000 in 5 years, discounted by 5.5% every 6 months, 962.31. If you want to let the financial calculator do all the work for you, then again, N mode, FV of 1,000. What's N? Well, it matures in 5 years, and they're semi-annual, so there's 10 half years. I percent, 11% divided by 2 gets us 5.5%. That's our discount rate. Payment, 100 per year, but 50 per coupon. FV is 1,000, so we have everything. Solve, negative 962.31, so the price is 962.31.